Dear The Percept followers, we are today here with Mr. Callan Carpenter. He's an Autodesk Vice President, Worldwide Major Accounts. Welcome, Mr. Carpenter.
Thank you. Very happy to be here.
Welcome to Turkey. My first question is, what's the target market of Autodesk?
Oh, well, Autodesk works in many different markets, but we have three primary industries that we serve. We serve the architectural, engineering, and construction industry. This is the industry that builds things, buildings, highways, infrastructure. We serve the mechanical world, the manufactured world, so factory design and the things that are designed and built inside of factories, such as automobiles or industrial equipment. And then finally, we serve the film and game, the entertainment industry. We provide software that's used throughout that industry for visual effects and other aspects of creating movies, commercials, TV shows, and games.
Could you give some samples about these movies show?
Well, in fact, almost any movie that has visual effects is guaranteed to have used our software at some point. In fact, for the last, many, many years, every nominee for the special effects Oscar for the best special effects has been an Autodesk user. So whether it's Toy Story, or it's Gravity, or it's Avatar, or it's the Lord of the Rings movies, all of those use Autodesk software.
Exciting.
That was very exciting.
How Autodesk adapt itself to the future? How can you move with the future?
So we are managed by a CEO, Carl Bass, who believes very much in the philosophy that only the paranoid survive. And what we mean by that is you have to be actively aware that the things you do today may be replaced by new technologies, new developments. And we ourselves were founded 34 years ago with the birth of the personal computer. When the personal computer came on the scene in the early 1980s, our founders had the foresight to recognize that this was going to change the cost equation for computing. And by lowering the cost of computing so dramatically, it could be made available to so many more people to do so many more things. Before that, you had mainframes, you had mini computers, only companies could afford this. But now, any house could have a computer. What possibilities does that create? And we created a whole business on this discontinuity between the old way to compute and the new way to compute. Okay, here we are 34 years later, and we have cloud. Cloud computing is the next big discontinuity in the cost of computing. If we're not paranoid about this opportunity, meaning if we're not willing to cannibalize our own business in order to take advantage of the new technology, someone else will cannibalize us instead. So this is how we think about the future. The future is full of disruptive technology. Disruption can be a risk, a threat, or it can be a wonderful opportunity. And for us, we choose to look at it as an opportunity.
Could you tell us what kind of disruptive technologies do you think is awaiting us?
So there's a number of technologies that we think are really changing the way products and buildings and even games and movies will be designed, manufactured, and even the way we expect them to be used and the experience that we will get. I'll just give a couple of examples. In the design world, generative design. Generative design is the idea that I have algorithms that I can describe a problem to the computer. I can put constraints on the problem. I can put objectives. For example, I might have a heat exchanger that needs to have a certain weight and exchange energy at a certain rate. I can give that to these generative algorithms, and they can design solutions by exploring thousands and thousands of possibilities. Why? Because we have cloud computing, and I can bring 10,000 CPUs online like that, and I can explore a solution space in a way I never could have before as an individual engineer. So design will be dramatically impacted by this ability to leverage the computer as a partner in the design process through generative design. Manufacturing. Many new technologies are impacting manufacturing. We of course have micro factories, we have advanced materials like composites, But we also see one that's very, very interesting to us, and that's additive manufacturing. The most common, not the only kind of additive manufacturing, but the most common that people think about is 3D printing. And 3D printing is becoming more and more capable every year. We don't mean printing plastic toys, we mean industrial strength 3D printing in metals, like aluminum and steel and so on. Being able to 3D print very large structures. There are companies in China that can 3D print a house now. Okay, so very disruptive, brings all kinds of interesting possibilities for flexibility as well as customizability to the manufacturing world. And then finally, in the area of how products are used and the experience that we have from them, products are getting smart. They have embedded microprocessors, embedded software, they have sensors, and of course, they're wirelessly connected to each other, to the internet, and this allows products to get smarter over time. Automobiles that have transmissions that learn the way you drive and adjust themselves to that are a good example. Many, many ways that this Internet of Things is going to drive a whole new set of experiences from the products that we buy, the buildings that we live in, the cars we drive.
One last question, just quick one. Is it possible to produce all human body parts with 3D printers?
Well, I don't think it's possible today, but certainly a very interesting area of research is biological science. And I think that will be one of the next big frontiers, is how we will use our design technologies to design biological systems, and how we will learn from biological systems how to design manufactured things. But we are seeing some pretty incredible things with 3D printing today. We know that simple organs like bladders have been successfully 3D printed. We know that living viruses have been 3D printed from a simple digital file. And there are many researchers today out there who are looking at how to print more complex body parts so that we can address certain diseases, that we can improve the quality of life. Whether we ever 3D print a whole person, I'm not so sure I can comment on that.
Thank you very much.
Thank you. My pleasure.